Hello and welcome to this third film from the calculations topic. This is also the third film about formulae, and it's the last one about formulae for now. It deals with how you turn an empirical formula into a molecular formula, and really it's just an example calculation, this one. Okay, so hopefully by the end of this film you'll be able to do just that. You'll be able to turn an empirical formula that you've found into a molecular formula using a little bit of extra information that you'd need to be given. Okay, so a reminder of the terms. Well, just remember that the empirical formula is a ratio, and it's the simplest whole number ratio, whereas the molecular formula tells us the actual number of atoms. Okay, so bear that in mind when you're doing the questions, because it might help you figure out a bit more about how they're done. Okay, so here we are. The first bit should be fine. The reason I say that is because we've done empirical formula calculations in the previous film. Okay, we've got carbon, we've got hydrogen, we've got oxygen here. Let's just put them in a table, find the number of moles, so that is 40 over 12.01. We've got 6.72 over 1.008, and we've got 53.29 over 16, so let's just put the numbers in. 40 divided by 12.01, 3.33, 6.72 divided by 1.008, 6.67, and 53.29 divided by 16, 3.33. So hopefully without using a calculator you can probably just see that that's 1 to 2 to 1, but you can always use your calculator to find that. Okay, plug those into the formula and we end up with CH2O. So that's something we should already be able to do. Now bear in mind, okay, this is an empirical formula. It's the simplest whole number ratio. So the molecular formula could be any multiple of this. In fact, it could be exactly the same as this, but it could be any multiple. Okay, so bearing that in mind, let's move on to the next slide. This is the second part. Okay, so suppose we know that the molecular weight of the compound is actually 180 grams per mole. Molecular weight, that's just another name for big M, okay, the molar mass. This tells us the mass of 1 mole of a substance, and remember, what we do to find that is we add up all the masses of the elements. Now we don't know what these numbers X, Y and Z are at the moment, but we know if we add X carbons and Y hydrogens and Z oxygens together, we're going to get 180 because that's its molar mass. Okay, so compare the actual molecular mass and the molecular mass of the empirical formula we've just found. Well, that would be 12 plus 2 plus 16, which is 30. Okay, this one has a mass of 180. So if we compare our actual with our empirical, so the molecular mass of the empirical formula, right, which was 30. So this is what we're going to do. We're going to divide our actual by the empirical mass. That's going to be 6. Okay, that means that our actual formula is 6 times as big as this one. Okay, so C6H12O6. Simple as that. Okay, so it's all about finding how many times bigger the molar mass is than the molar mass of this substance that you've just calculated the formula of. Okay, that's in year 11. It will pretty much be that simple. You might find an extension question in year 11, or if you're doing it in year 12, it's a little bit harder. You might have to figure out what the molar mass is before you can use it in that second stage. So for example, let's say we were using PV equals nRT to find a molar mass. Let's just remind ourselves what molar mass means. It's grams per mole, so mass divided by moles, right? What's N according to this equation? Well, N is PV on RT, okay? So if we take M and divide it by this, right? M divided by PV on RT, that's the same as M multiplied by PV, RT on PV, okay, which is MRT over PV. So if someone said to me that 10 grams of a certain gas occupied, whatever, 100 litres, at a temperature of 300 degrees centigrade and a pressure of 101.3 kilopascals, I could figure out what the molar mass was, right? So I know that the molar mass is equal to this lot, and once I know the molar mass, then I can do the second stage of the empirical to molecular formula calculation. Okay? As I say, in year 11 that's not really going to be a concern of yours, right? But in year 12 that's certainly the kind of thing that you're going to see. And as usual with the calculations, I'm afraid it's all a question of practice. If it seems hard, you probably need a bit of help, or to watch a film again and check your notes. Okay? If you need a bit of help, please come and get it. There's no point struggling on your own, right?